When we look at cells, cells are the first theory that we're going to explore in this class. Now remember, a theory is a well-substantiated explanation for something that you see in nature. It's explored through many, many different avenues. It's not just one piece of science. It's science from many, many different aspects. Now, cell theory tells us two things. The first is that all organisms are composed of at least one cell, and that all cells came from pre-existing cells. So the implication for this is that every form of life on this planet can trace its ancestry back to one or very few common ancestors. And then through evolution, these cells have changed. Now, when we look at cells, there are two basic fundamental types. The first are prokaryotic, and they're going to be the very primitive type of cells. And the next kind are eukaryotes, and the eukaryotes are the more advanced. Now, with the prokaryotic cells, there are three distinctive features about them. Now, when I go through and give you the list of three things, it's really the third piece that drives the second, which drives the first. So just bear with me, we'll go through it, and then I will explain why the third component is so important. Well, the first thing about prokaryotic cells is they are small. If they are small, it means they have to be relatively simple. And simple means that they have only a few pieces to them. They still have to do all the metabolic processes that we looked at a couple of days ago, but their mechanisms and the number of parts that they have are relatively small. Now, why are they small and simple? They are small and simple because they have no internal membrane-bound organelles. They're going to have a membrane on their outside, but once we get into the inside of the cell, there are now no more membranes there. And in a moment, I'll explain why these membranes are important. All right, when we contrast the prokaryotic cell with the eukaryotic cell is exactly the opposite of the prokaryotes. The eukaryotes are generally larger. They're more complex, and again, complexity means more pieces can be added, more components are in the cell. Now, why can they be large and complex? It's because they have internal membrane-bound structures, which we now can call organelles. By having organelles, it means that all the necessary